Hello, everyone. This is another study of Oahspe.com podcast video, copyright for YouTube. Today's subject is stellar and planetary magnetosphere vortices. Now, on my home page near the bottom, it says Oahspe contains much information in it that has proven to be true. Example: Oahspe said that an invisible the Earth has a invisible vortex around it, and that the vortex was comet shaped. The vortex was 42,000 miles from the surface of the Earth to the rim of the nose, with variations. The tail of the vortex stretches somewhat beyond the moon. Oahspe said that magnetism was one of the manifestations of the vortex. In 1958, when the U.S. first sent up space satellites, scientists discovered the invisible magnetosphere of the Earth. They discovered that the magnetosphere was comet-shaped. Scientists also discovered the magnetotail stretched well beyond the moon. The magnetosphere was first theorized in 1931, but Oahspe had that information in 1881, original manuscript before publishing. An astronomer in 1997 said, quote, "The Oahspe author has described the interaction of presumably the solar vortex with planetary or cometary vortices and deduced correctly what the effect of solar emanations on a diffuse spherical structure would be." And scrolling down, Oahspe Book of Cosmogony and Prophecy, Chapter 1, verse 2, 5, and 8 says, "The earth floateth in the midst of a vortex, the outer extremity of which is somewhat beyond the moon. The outer rim 42,000 miles broad of the earth's vortex. The greater diameter of the vortex is east and west, the lesser diameter is north and south. At this age of the comet, it showeth nearly the configuration of its own vortex, its tail being the invortexia. If it appear to the east of the sun, its tail turneth eastward. If west of the sun, it turneth westward." From the book Exploring the Upper Atmosphere by Richard A. Craig, copyright 1968, pages 136 to 137 says, quote, "The magnetosphere, beyond about 30 Earth radii on the side of the Earth away from the sun, on the side away from the sun, on the side away from the sun, there is a much more extended region called a tail, which may reach out well beyond the moon. Although this question is not yet settled, our understanding of the magnetosphere is very limited because only the far-ranging space probes can study it." I'll read that again. Only the far-ranging space probes can study it. A vast amount of work remains to be done. Now, that was in 1968. Since then, scientists have studied it a lot more and have answered the question, have settled the question about its tail extending beyond the moon. That has been settled in other things. From the book Aurora Borealis, The Amazing Northern Lights, copyright 1979 by S1 Akasofu, page 69 says, "Our understanding of the aurora began to improve dramatically about 10 years ago as a result of a very intensive study. Scientists view this phenomena in terms of an electrical discharge. And in brackets, I wrote, as did Oahspe in 1881. Powered by the magnetosphere generator. In brackets, I put the Earth's vortex, Oahspe says. And then it goes on to say, they are now engaged in proving this theory with information gathered by satellites and rockets, information unobtainable before the space age. I'll read that again. Information gathered by satellites and rockets, information unobtainable before the space age. Page 71 of Akasofu's book says, quote, a cavity shaped like a comet is formed around the Earth. It is the Earth's invisible magnetic field. The cavity is called the magnetosphere. On page 72 of Akasofu's book, it says, Professor Sidney Chapman, a physicist who with his colleague Vincenzo Ferraro was the first to theorize the formation of the magnetosphere in 1931. Now that was 50 years after Oahspe contained information about the magnetosphere vortex, describing its comet shape, its size, and other characteristics 50 years before in 1881, which according to scientists, information unobtainable before the space age. So how did Oahspe have this information if it was unobtainable before the space age? Now scrolling back up, and going to another page on studyofoahspe.com. And that page is called Magnetospheres, Solar Planetary Vortex, 3D Hologram. And clicking on it, there it is. Study of Oahspe, Magnetospheres, Solar Planetary Vortex, 3D Holograms. Now it says right there, plate Tau Sang in Oahspe shows the solar system vortex, solar wind, and the planetary vortices, magnetospheres, and the rotational axial tilts of the planets. Oahspe had an accurate drawing and description of the planetary magnetospheres decades before they were theorized and discovered, and had an approximate depiction of the rotational axial tilt of the planets. And there you see a picture of the sun, and there's the magnetosphere around the Earth. And to the right of that is Oahspe's plate, image of the plate in Oahspe, showing the sun right there, and the Earth right there. And you can see the comet-shaped magnetosphere of the Earth with its wide end tail, rounded nose and head, nearer the sun, and its wide tail pointed away from the sun like a comet. That was pictured in Oahspe. Right there and right there. Right there you have the image drawn by from space scientists, and here you have the 1881 Oahspe plate image of the sun, the earth, and its comet-shaped vortex or magnetosphere. Now, as I said previously, an astronomer in 1997 said the Oahspe author has described the interaction of presumably the solar vortex with planetary or cometary vortices and deduced correctly what the effect of solar emanations on the diffuse spherical structure would be. And the key here is what the astronomer said. He said the Oahspe author has so on and so forth, and said and deduced correctly. So he's acknowledging, this astronomer acknowledged that Oahspe had deduced correctly its information about the interaction of the solar vortice with planetary or cometary vortices and their effect and spherical structure, what it would be. Now, here I have some images, and let's see what's written below there. Now, it says here, one anti-Oahspe person gave his false, see images above for proof, opinion, as Newborough really did a poor job of plagiarizing Swedenborg and Descartes. He just copied their ideas. He said Newborough just copied their ideas. Now, I went on to say here on my website, you can clearly see above the comparison and difference between Descartes' planetary and solar vortices and Oahspe's planetary and solar vortices. And right above, this is what I'm referring to, these images. On the left is Descartes' planetary and solar vortices. You can see right there that's quite a bit different than on the right, what is pictured here, and that I have outlined in red the shape and structure of the planetary vortice, of Earth's planetary vortice. Look at how different that is than what Descartes wrote or drew. And you can see how modern day images from NASA of the Earth's magnetosphere and the depiction in Oahspe of the planetary vortice that I have outlined in red there. See how very similar and almost exactly the same is the NASA image, the comet-shaped image. Much different than on the right again of what Descartes depicted. And I have sources for these images. Here's one from nasa.gov images, and I'll click on that link, and there you see. That's where I got that images from. It shows the Earth's magnetotail and how it points away from the sun. The same is depicted in Oahspe in 1881. What I showed you before, right there. There's the Earth in its comet-shaped vortex or magnetosphere with the wide end tail pointed away from the sun. There's the sun right there. The same as what I just showed you in that nasa.gov images link. And underneath that, there's another link, history.aip.org, history exhibits, cosmology, ideas, so on and so forth. Clicking on that one, and it shows the Descartes vortices right there. And that's where I got those images from. It says right there, image of Descartes vortices from his 1644 book Principia Philosophia, or Philosophia, basically his principal philosophy dealing with um, the planets and the sun and their vortices. Quite a bit different. As you can clearly see, Newborough did not copy his information and images from Descartes, as this anti-Oahspe falsely claimed. Now see here, I have colorized words and phrases that correlate with each other. I have in white here, you see false, in white plagiarizing Swedenborg and Descartes and copied their ideas, in opinion in white. And then in green I have proof, in green comparison, and in yellow I got difference between Descartes' planetary and solar vortices and Oahspe's planetary and solar vortices. Now compare this colorization I did to what's written in Oahspe Book of Discipline, chapter 8, verse 5. It says, "For which reasons thou shalt explain that only facts well known or comparatively proven are light, and opinion is not light." So in yellow, I highlighted only facts well known, and in yellow above I highlighted difference between Descartes' planetary and solar vortices and Oahspe's planetary and solar vortices. It's a fact that they're different, so I highlighted them both in yellow. And then in green, I highlighted comparatively proven. And I highlighted above comparison and in green, and highlighted in green proof. So I've compared Descartes' planetary and solar vortices to Oahspe's planetary and solar vortices, and have compared them and proved that they are different. And in yellow, as I said before, I highlighted only facts well known, and also in yellow are light, and that's comparable to the highlighted part of difference between Descartes' planetary and solar vortices and Oahspe's planetary and solar vortices. And in white, I highlighted an opinion is not light. And then I highlighted the in white the anti-Oahspe's opinion. His words were his false opinion that Newborough plagiarizing Swedenborg and Descartes, that he copied their ideas, copied their ideas. That is an opinion, a false opinion, which is not light, as I've shown by comparing the two. Now, I go on to say here, René Descartes' illustrations are different from Oahspe. Descartes shows planetary or sun vortices touching each other, whereas in Oahspe, the planetary vortices are spaced far apart and the correct sizes that correspond to the magnetospheres of the planets, as you'll see in these images right here of the Descartes on the right, and right there Descartes on the left. And of course I showed you where I provided a link to that, of the Descartes images of planetary and solar vortices. And then I go on to say Descartes' celestial vortices are 5 and 6-sided polygons, pentagons, hexagons, etc. Oahspe's celestial vortices are cone-shaped like magnetospheres of the planets in the solar system, which is the correct shape, not the shapes that Descartes had. So if Newborough would have copied Descartes' ideas, he would have just have drawn the vortex of the planets in the solar system as looking like that. You see these 1, 2, 3, 4, 5, 6-sided shape right there, and a 1, 2, 3, 4, 5-sided pointed and sided shape right there. Quite different than this cone shape right there. Now I go on to write, John Ballou Newborough in Oahspe, 1881, drew a picture shown top of page on the right of the Earth's magnetosphere vortex and the solar wind sun's vortex 77 years before they were discovered. Newborough correctly pictured the cone-shaped magnetosphere of the Earth with the wide end of the cone pointing away from the sun and the narrow end closest to the sun, as I showed you before. Now right here it says magnetosphere chronology. So I'm providing the evidence when the magnetosphere was discovered. 1958, as I said before. Explorer 1, built by Van Allen and his Iowa group and launched by the U.S. January 31st, observes the radiation belt. Explorer 3, launched in March, comes up with the first clear evidence for its existence. The existence of the magnetosphere. The first clear evidence, 1958. 1958, Eugene Parker, Chicago, proposes the theory of the solar wind. 1959, and the solar wind is just what Oahspe calls the solar vortex. 1959, Thomas Gold proposes the name magnetosphere. 1961, the magnetopause, boundary between magnetosphere and the solar wind, is observed by Explorer 12. The measurements confirm predictions made in 1931 by Chapman and Ferraro, who I mentioned earlier. Now, the magnetopause in Oahspe is called the Bridge of Chenvat. That is the boundary between the Earth's vortex and the Ethereal heavens, which scientists call the magnetopause. And that was discovered in 1961. The boundary between magnetosphere, which is the Earth's vortex, and the solar wind, the solar or master vortex. So that's the magnetosphere, the boundary. In Oahspe, it's called the Bridge of Chenvat, which in ancient times, maybe in Persia or the Zoroastrian religion, mentions the Bridge of Chenvat. In 1964, IMP-1, which is the Interplanetary Monitoring Platform 1, reports a large bow shock formed in the solar wind ahead of the magnetosphere and a long magnetic tail on the night side of the Earth. There it is, 1964. That long magnetic tail on the night side of the Earth. That would be on the same side away from the sun, as I've shown you before, which is right there. That was depicted in Oahspe, but according to this chronology, this long magneto tail wasn't discovered until 1964 by the Interplanetary Monitoring Platform 1. And the source for that is wikipedia.org, magnetosphere chronology. And clicking on that link, there it is. And that's where I read right there. The 1958 Explorer 1, built by Van Allen and his Iowa group, launched by the U.S. January 31st, comes up with the first clear evidence for its existence. So going back, from the book Exploring the Upper Atmosphere by Richard A. Craig, copyright 1968, pages 136, 137, says, our understanding of the magnetosphere is very limited because only the far-ranging space probes can study it. Only the far-ranging space probes can study it. A vast amount of work remains to be done. And as I said before, on page 72 of Aurora Borealis, The Amazing Northern Lights, copyright 1979, by S.I. Akasofu, it says, Professor Sidney Chapman, a physicist who, with his colleague Vincenzo Ferraro, was the first to theorize the formation of the magnetosphere in 1931. And that was reiterated in that link, Wikipedia link on the magnetosphere chronology. Now here is a definition in the Wiktionary instead of the dictionary, the Wiktionary, vortex. And it says, noun, vortex, plural, vortexes or vortices, a whirlwind, whirlpool, or similarly moving matter in the form of a spiral or column. And then spiral, definition of spiral by lexico.com. And the other definition above was wiktionary.org. It says of spiral, winding in a continuous and gradually widening or tightening curve, either round a central point on a flat plane or about an axis so as to form a cone, a spiral pattern. So it said of a vortex, a whirlwind, whirlpool, or similarly moving matter in the form of a spiral or column. A spiral or column. And definition of spiral was winding in a continuous, gradually widening or tightening curve either around a central point on a flat plane or about an axis so as to form a cone, a spiral pattern. And that cone that it's talking about is depicted in Oahspe right there, and also depicted in modern NASA images of the magnetosphere, the invisible magnetosphere. So that's the cone of the vortex, the spiral cone. Now, Oahspe also depicts Neptune in its vortex in its plate of the solar system. And there's Neptune, and there's its cone-shaped vortex, tilted at an angle. And there's an image showing the tilt of Neptune. And that's its rotational axis that I've outlined in red. And there's an arrow pointing toward the sun. And adjusting the image, the plate image in Oahspe of the solar vortex and the planetary vortexes, and adjusting the image to where the sun is to the left of Neptune, and then I outlined the tilt, the angle tilt of Neptune's vortex. You see it corresponds with the rotational axis right there, outlined of Neptune. And I write there above images of Neptune's magnetosphere vortex with the sun to the left instead of to the right as it shown in the original plate image. I just reversed it. Shows the diagonal tilt of the magnetic field from southwest closest to sun to northeast farthest from sun. John Newborough's drawing in 1881 closely matches data gathered by NASA's Voyager 2 probe in 1989. as it flew through Neptune's magnetic field. This was 108 years after Oahspe was written. Same as for Uranus. See comparison of images below. There I show, well, first of all, here's the Oahspe plate. There is the vortex of Uranus. There's the red arrow pointing toward the sun. And there's the modern day image. There's the modern day image of Uranus and its rotational axis. You see that red line there? It's about the same angle as the red line I drew on the vortex of Uranus. And there's the arrow pointing to the sun, showing the sun to the left. And they match. And then I write here above images of Uranus's magnetosphere vortex with the sun to the left instead of to the right shows the rotation axis of Uranus from southwest closest to sun to northeast farthest from sun. Tilted magnetic fields. The magnetic fields of Uranus and Neptune, useful as a picture of what the external field looks like. And I have a link to that site from tufts.edu/cosmos. And then underneath that, you can't take a picture of the magnetosphere, the bubble that the planet's magnetic field carves in the solar wind, because it's invisible to the naked eye. Everything is derived from the local measurements that the spacecraft made as it flew through. Jonathan Eastwood, a physicist and space scientist at Imperial College London, told Space.com. Researchers constructed the distant planet's magnetic field by combining data gathered by NASA's Voyager 2 probe in 1989 with a new model that was originally built to describe how plasma acts in the lab. The new results paint a picture of a field continuously in flux, tilted and bubbling out to one side. And there's a link to that on space.com. Neptune's strange magnetic field video. And then I write underneath that, how could Newborough have known that Neptune's and Uranus's magnetospheres were tilted like that, when planetary magnetospheres were not discovered until after the space age? The magnetosphere was invisible to the eye, and there were no spacecrafts in the 1880s to fly to Neptune to gather data. Another good question. And the images of the planetary vortices come from plate 47 of the 1882 edition of Oahspe. Plate 47 drawing, Tao Sang in Oahspe, shows the cone-shaped field vortex around Jupiter, which right there is Jupiter, and there's this vortex right there. And Tao is a verb. The name of the plate is called Tao Sang. And it says a verb of a motor vehicle or boat, pull another vehicle or boat along with a rope, chain, or towel bar. Dictionary.com, answers.com, Merriam-Webster. Oahspe Book of Safa, Interpretation 38, Sang, because the plate Tao Sang has the word sang in it. Now I've just given you the definition of Tao, and now I'm giving you the definition of Sang, S-A-N-G. It says 38 Sang in the Book of Safa, panic, a panic word, which was the original language, Pan language, from the continent of Pan. It says equals stars, Sang equals stars. Safa, Oahspe 54, Osiris. So there again, the Book of Safa containing scientific information about, in this case, Tao Sang, the plate Tao Sang, Sang standing for stars. And that relates to the solar system. To master others per force, Tao. So Tao the plate named Tau Sang is also called the master vortex. Solar vortex is the master vortex. And it says there to master others per force, Tau, in the book of Sapa. So Safa is making sense of the name of the plate, Tau Sang. And then I write underneath that master sun's vortex pulls the stars, planets by force equals Tau Sang. And Oahspe describes planets as stars also. So that relates to the word sang in the book of Sapa equals stars. Because from a distance, the light from planets also look like stars. And the Earth is called the red star in Oahspe. Now that image right there says Jovian, which is Jupiter, magnetosphere / solar wind interaction. Above drawing of Jupiter's magnetosphere vortex showing the cone shape. So there you can clearly see this modern scientific drawing of Jupiter's magnetosphere, and you see the cone shape. And below that I write, the magnetosphere of Jupiter is responsible for intense episodes of radio transmission. The energy is transmitted out along a cone-shaped surface. There again. Jupiter rotates once every 10 hours, and the cone rotates within it like a lighthouse beam. Plate 47, Tau Sang in Oahspe shows the cone-shaped field vortex around Jupiter. And I'll just scroll down and show you right there. There's the modern scientific drawing of Jupiter. Of Jupiter's cone shape. And there I've enlarged from an enlarged image from Tau Sang plate in Oahspe. They're showing Jupiter cone-shaped vortex. It says there the magnetosphere of the 5 magnetosphere, the conical shape. So the shape of the vortex is conical or cone shaped, and Descartes did not draw cone-shaped vortices, but Oahspe did. Before they were even discovered. Decades before they were discovered. Over 50 or 60 years before they were discovered. So continuing reading where I left off. Jupiter's Magnetosphere, Annual Review of Astronomy and Astrophysics, Volume 15, 389 to 486. Volume publication date September 1977. Jupiter's magnetosphere, discovered 20 years ago by radio astronomers. Let's see. 1977, and 20 years earlier would have been 57, or let's see. I don't think it was discovered in 57, so that would have been, this must have been written 20 years after Jupiter's magnetosphere was discovered, which probably was in 1977. Either way, 57 or 77, that's many decades after Oahspe was written and showed the cone-shaped magnetosphere around Jupiter. But anyway, as I was reading, discovered 20 years ago by radio astronomers, has recently been traversed by the Pioneers 10 and 11 spacecraft. And I have a link to that. So if you want to read it, you can click on it. Visit my website and click on it at your leisure. Oahspe had a drawing of Jupiter's cone-shaped magnetosphere in 1881. Jupiter's magnetosphere wasn't discovered until 1957, 76 years after Oahspe was typed. Now I wrote 57 there based upon the publication date of that being September 1977, and it said Jupiter's magnetosphere discovered 20 years ago by radio astronomers. But that may have actually been in 1977. And this article could have been 20 years after that. But either way, 57 or 77, as I said before, it was many decades after Oahspe was typed. See images below from modern science in the Oahspe of Jupiter's cone-shaped magnetosphere vortex. And that's what I showed you already. And here's Tau Sang plate again. And I drew the red line through Jupiter's vortex. And there's the red line of Neptune's. And here is the obliquity of the planets, basically their axial tilt. And there's showing Jupiter almost straight up and down. And as you can see, Nubero drew Jupiter's straight up and down. And Neptune has an angle right there, which matches pretty close to that angle drawn by Nubero in 1881. And there's a link to the axial tilts of the planets of the solar system, called the obliquity of the planets. Obliquity. When you go oblique at an angle. Images above shows rotation axis and obliquity, axial tilt of Jupiter and Neptune. Jupiter spins nearly upright, perpendicular, vertical, as indicated by the drawing of Nubero under angelic control in Oahspe, which I highlighted there in red, which matches closely to that to the actual axial tilt of Jupiter, which I highlighted in red. So they match. So you can see Nubero's drawing of planetary and solar vortices were scientifically accurate and were not copied from previous scientific journals and publications, and were not copied from Descartes or Swedenborg or anyone else. In-depth Jupiter NASA solar system exploration. Orbit and rotation. This means Jupiter spins nearly upright and does not have seasons as extreme as other planets do. Axis. National Geographic Society. Some planets such as Mercury, Venus, and Jupiter have axes that are almost completely perpendicular or straight up and down. Earth axis is not perpendicular. It has an axial tilt or obliquity. There's that word. And I've already showed you the straight up and down to Jupiter. There is images of planetary magnetospheres showing Mercury, Earth, Saturn, Jupiter, Uranus, Neptune, and so forth. Figure 5 says the magnetosphere of the 5 magnetized planets. Boxes illustrates the relative sizes of the magnetospheres. The conical shape on the left of each planet represents the bow shock, the conical shape. The swept-back dipolar lines represent the planetary magnetic field. The size of the sun is shown in the Jovian magnetosphere for scale. So right there, the sun. And then underneath that on my website, I write, there are 6 magnetized planets in our solar system that have magnetospheres. Mercury, Earth, Saturn, Jupiter, Uranus, Neptune. Oahspe showed a picture of all of them except Mercury, which I put in brackets, which may have been too small and too near the sun to show in the picture in plate 47 Tau Sang. I'll show you what I'm talking about there. There's Tau Sang, and as you can see, there's the Earth and there's the sun. So to show Mercury, which would have been closer than the Earth, wouldn't have been feasible in that image, in that scale. So that's the reason why Oahspe didn't show Mercury in that drawing, but it showed all the other planetary magnetospheres of the solar system. Oahspe correctly showed the cone shape of the planet's magnetosphere 85 years before they were discovered by space probes. 85 years before they were discovered by space probes. Oahspe had that scientific information. Now it says here, see Oahspe plate 47 tile saying above shows Uranus' magnetic field twisted to a pointed screw shape and tilted at a strange angle, 60 degrees. Oahspe plate 47 tile saying was drawn 105 years before Voyager 2 collected data from Uranus. Voyager 2 mission. That encounter took place on January 24th, 1986. Nearly everything we know about Uranus was learned at this time. Uranus is different from any other planet in the solar system in that its axis of rotation is tilted 98 degrees. Another strange fact about Uranus is that its magnetic field is tilted at a 60-degree angle to its axis of rotation. The tail of the planet's magnetic field is twisted like a corkscrew. And there's an enlargement I have of Uranus, and then you can see the angle of the lines there shows the screw-like twists, which there's a corkscrew to the right, showing you a comparison. And twisted, it says magnetic field is twisted like a corkscrew. So as you can see in the corkscrew, it usually starts out at a wide cone shape and then comes to a point there. It's pictured there, and then you can see it goes in the image that Newborough drew of Uranus's magnetosphere or vortex. It has the wide cone shape going down to a point. And just as you see the twist there in the corkscrew, there's the enlargement showing the lines, which represents the vortexian twist of the vortex going down to a point, like a corkscrew. And I write there, above magnified view of the Uranus magnetosphere drawn by John Ballou Newborough in 1881, showing the pointed corkscrew tail, an opposite wide end, and the diagonal twisting lines, which I showed you there, the diagonal twisting lines that differ from the solar system almost vertical rotational lines, which you can see there. There's the lines of the solar system, and there's the lines of Uranus's twist. Notice the corkscrew has a pointed tail, diagonal lines of twist, and wide opposite end like the magnetic field of Uranus. Yeah, which I showed you already with the corkscrew. Oahspe Book of Cosmogony and Prophecy 3, verse 11. As light and heat and magnetism and electricity are all one and the same thing, which are the manifestation of vortexian currents under different conditions. See plate 47, tile saying of Oahspe. It shows no tilt to magnetic vortexian field of Saturn. Only planet in plate 47, tile saying with no tilt. So let me scroll up to that and tile saying. And you can see Saturn right there. And basically, it's not tilted like the others. It's pretty much straight on in relation to the whole vortex. Which, let me... Yeah, there it is right there, Saturn. Which shows the solar system at about a 10-degree angle approximately. Yeah, right there. And the same pretty much for Saturn. So there's not any tilt to it. So it goes on to say, only plate in 47, plate 47, only planet in plate 47 tile saying with no tilt. Saturn's very asymmetric magnetic field. No detectable secular variation or tilt. Saturn is the only planet in the solar system whose observed magnetic field is highly asymmetric. At least a small deviation from perfect symmetry is required for a dynamo-generated magnetic field. So you can read the rest of that on my website if you want. But the main point is it no tilt. And that's the way Newborough drew Saturn, with no tilt. And right there I write above solar system is a little more than 10 degrees angle for straight, no tilt. And that was the same. Right there I write above Saturn is a little more than 10 degrees angle for straight, same as solar system, no tilt. Right there. Which is different from the other planets in the solar system and the other planets drawn by Newborough. But that wasn't discovered till many decades later by space probes that scientists discovered that. It wasn't until 1979 that scientists discovered that Saturn had a magnetic field and that its magnetic field was unlike that of any other planet. There was no tilt to the rotation axis. In 1881, 98 years before scientists discovered Saturn's magnetic field with no tilt, John Ballou Newborough in Oahspe had drawn a picture of the magnetic field vortex of Saturn with no tilt. Newborough drew the magnetic field of 5 planets in the solar system. Saturn was the only one he drew that had no tilt, as can be seen on the Tau Sang plate. And more than 98 years later, scientists have discovered that Saturn is the only planet in the solar system with a magnetic field with no tilt, just as Newborough had drawn. But man did not have the technology to know that about Saturn in 1881. This is another advantage that Oahspe has over the Bible and the Quran and other spiritual books, is it has images of cosmic knowledge that did not exist. It had drawings of cosmic knowledge that did not exist on Earth at the time Oahspe was written. Now right there, NASA's IBEX proves first view of the solar system's tail, July 10th, 2013. It has long been assumed that our solar system, like a comet, has a tail, just as any object moving through another medium, for example, a meteor traveling through Earth's atmosphere, and so on and so forth. NASA's Interstellar Boundary Explorer, or IBEX, Interstellar Boundary Explorer, has mapped the boundaries of the tail of the heliosphere, something that has never been possible. Scientists described this tail, called the heliotail, in detail in a paper published on July 10, 2013 in the Astrophysical Journal, by combining observations from the first 3 years of IBEX imagery. The team mapped out a tail that shows a combination of fast and slow-moving particles. There are 2 lobes of slower particles on the sides, faster particles above and below, with the entire structure twisted as it experiences the pushing and pulling of magnetic fields outside the solar system. And that's from nasa.gov content. NASA's IBEX provides the first view of the solar system's tail. Now look at that image, NASA image of the solar system in its cone shape, and tell me that doesn't look like what Oahspe drew of the solar vortex in 1881. Tell me. A long twisted tail like a snake or a serpent, which is what Oahspe calls the solar system. It calls it the Great Serpent. And look at that imagery right there of the solar system, the sun's tail its own magnetosphere called the solar wind, its vortex. And right below there, other stars show tails that trail behind them like a comet's tail. Scientists use NASA's Interstellar Boundary Explorer to confirm that our solar system has one too. From top left and going counterclockwise, the stars shown are LL Uranus, BZ Cam, and Myra. Image credit NASA /HST /R Casalagno /Galax. So the /HST is Hubble Space Telescope. That's where those images come from. Now, take a look on the left here of Oahspe's plate drawing of the solar vortex and these NASA Hubble Space Telescope images of the solar wind, and see how they're similar. Tell me that Oahspe didn't have advanced knowledge in 1881, decades before scientists discovered it. Tell me he copied Swedenborg and Descartes or other scientific journals published before. Tell me where what he published, what he copied, and where it is that had that knowledge before he drew it in Oahspe. Tell me, I'd like to know. But look at this. I outlining of the solar wind, especially that right there. Look at that outline of that image, and look how similar it is, and almost the same as what's drawn in Oahspe. Even this part right here. See where the back end, where it curves in and then goes around, and look right here where it curves in and goes around. See the cone shape right there? Notice the stellar solar heliospheres with tails mapped in image by NASA Hubble Space Telescope and IBEX, outlined in green compared to Oahspe drawing under angelic control by Newborough of solar stellar vortex. Notice how very similar the NASA Hubble Space Telescope and IBEX images are to the Oahspe drawing, and how different they are from Descartes' planetary and solar vortices, red outline below. So below I show you there's Descartes' drawings, and there is Oahspe's drawing and the NASA Hubble Space Telescope images, and how very different they are from Descartes. Newborough's drawings in Oahspe look like something out of a modern scientific publication. See for yourself. And see how different they are from Descartes, which one anti-Oahspe said that he just copied. Now, right below here, I write, Descartes was way off in his depictions of planetary and solar vortices, and Oahspe was spot on. The comparisons above prove that. Quote, the tail is our footprint on the galaxy, and it's exciting that we're starting to understand the structure of it, said Christian. The next step is to incorporate these observations into our models and start the process of really understanding our heliosphere. Eric Christian, IBEX mission scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The tail is our footprint on the galaxy. And that's similar to pesta equals footprint, footstep, track, trails. The Yala Pesta in Oahspe, in the Book of Cosmogony and Prophecy, that I translated as the meaning of the name Yah is graceful, the meaning of the name La is sun, Italian to English, pesta, footprint, footstep, track, trails. And Eric Christian, the IBEX mission scientist at NASA's Goddard Space Flight Center, said, the tail is our footprint on the galaxy, referring to the tail of the solar wind, of the sun's vortex. So there's some more images. So there you have it. Um, that is it for today's podcast, for this podcast. Thank you for watching and listening, and stay tuned for another study of Oahspe.com podcast video on YouTube.